So with that, um, I will go back to my original screen here. And well, I will begin. So welcome everybody to the inaugural presentation for Introduction to Stargazing and the Universe. What we hope to be doing is a continuing series that will cycle over the course of the year and perhaps 2 years, and introduce everybody in a hopefully friendly and gentle way to the night sky, the things we can see. First off, though, I would like to say thank you to the Royal Astronomical Society of Canada, the RASC, for their use of the Zoom webinar functionality, and also thank in particular Luca Vanzella for doing the legwork in getting this all set up and walking us through how to run one of these. And to my cohort, John Stolte, who's in behind the scenes, reading your question and answers and anything on the chat. One of the things that I'd like to, before I actually
just
begin.
a note here, Alister, sorry to interrupt. Yeah, we just want to point out too, I'm recording this and we'll upload it to YouTube when we get a chance, if I can figure out how to do that.
Okay,
just
no
so
problem
we all
then.
know we're being recorded.
Yeah, no swearing. So this is a monthly get-together somewhere between a course and a book club. The original idea was to start this when the Queen Elizabeth Planetarium was to open, and it originally was scheduled to be opened last fall, and it got moved to opening, grand opening this summer, along with the International Planetarium Society conference that was being held here in Edmonton. And that essentially every Wednesday, the Royal Astronomical the Edmonton Center would have some form of event going on, sometimes members only, sometimes open to the public, such as this one. And as noted at the bottom of the current screen, the first Wednesday of every month, What is Up in the Sky this month, hosted by our president, Jeff Robertson. So it was also intended to be a little, well, partly conversational, so give me a little time to talk about a particular topic, and then we can essentially open up to question and answers. There are going to be some things that you will undoubtedly put in the question and answer that are either off topic or not immediately relevant, so we'll sort of bump that to the end of the presentation, where we'll hopefully be able to address your question in a sort of first come first serve kind of way. Some of the questions we may answer in sort of one sentence, and hey, if you don't mind, we'll deal with that at the next session, or we're planning on doing this in later summer when the planets are up. So sometimes your questions may be a little delayed, but hopefully we could at least get you on your way. So the idea is to introduce you to the sky, the stars, the planets, much as if we were sitting around a campfire looking up. First and foremost, it's all about looking, what you can see with your eyes. No telescope is required. Binoculars are great if you have them. At some point, we can probably go through a little bit of recommendation of what to get if you're looking at binoculars or a telescope. But first off, the big heavy red letter warning: do not go out and immediately buy telescopes or binoculars in order to feel that you're set up for this. It's very easy to find on Kijiji some really bad stuff, and even for sale at the local camera store. things that are, well, maybe not bad, but inappropriate, or gee, there are much better options for you. Because it is very easy to go and get something that, the sort of thing is, I want to buy a bicycle, and you end up getting a tricycle for a kid, and you just go, well, that's not the thing you kind of need. So hopefully resist the urge to run out and buy a telescope or binoculars at this point. We'll certainly be able to offer advice as we go along with these things. We're guessing that quite a number of people are interested in astronomy. They may have already joined the center and then felt perhaps, oh, it's just sort of too big, too much information, and have either let the membership go, or maybe you're here looking for a little bit more guidance, a hand up. Before I really get into tonight's topics, I'd like to let you know in advance that I do not intend to cover black holes, dark matter, dark energy, or how stars or planets are made or evolve. As interesting and cool those topics are, they are covered elsewhere, especially at our monthly meetings of the Edmonton Center that are also open to the public and available by Zoom. So some of the really weird things about space and astrophysics, gravitational waves and all that, we're not going to be dealing with here. This is really all about what you can see when you walk out your back door or onto your balcony, and what can I see with my eyes. Also, you may have come here thinking we'll be talking about astrology, the belief that the positions of the heavenly bodies affect your life and character or behavior, but this is about the science side of looking at the sky. We will go back in time to some of the astrological roots, but also look at some of the Aboriginal cultures. There's a lot of interesting things that cultures from across thousands of years have given us and have lasted right up into the modern day. So we'll be talking about some of those. And just right off the top, you probably have realized I do not have a degree in teaching. And this is about the third time we've used Zoom, so please forgive the hiccups and pauses that are bound to occur. Okay, so let me change the sharing here, and we'll start in on Venus. I will be in part I think the word is covering or overlapping a little bit with Jeff Robertson's What's Up in the Sky this month. But in a way, that's okay, because there's half a chance you're going to forget some of the things I mentioned tonight, and you'll forget some of the things that Jeff will tell you in a couple of weeks, and we'll kind of cover things until eventually you'll remember things. I like to use the analogy. It's a bit like moving to a new city and being completely unfamiliar with which way is up and where things are. But we're going to essentially show you how to get to the Tim Hortons without a GPS, and you'll be able to eventually learn the sky much as you would learn the street patterns in a new city when you move there, or exploring the neighborhood as you might on a bicycle. In the FAQ, I've posted a link to the software that I'm showing here. It's called Stellarium. It is free software. There's a web version, so you don't even have to download anything, but this is just a classic download, install, in 5 minutes, you're up and running. Also on the RASC Canada website, there's a series of homebound astronomer or Hitchhiker's Guide to the sky, and there is an entire session on Stellarium, installing it, and how to turn features on and off. So don't worry that I'm going a little bit too fast. I don't quite expect you to all follow along. The software is fairly intuitive, but at the same time, it allows you to do a whole bunch of pretty detailed stuff. And I am far, far from being an expert on this. I have the app on my phone. It costs me $1.99. But if you have an app like Sky Safari or Starry Night, those will do equally as well. Many of these, they're called planetarium software because it's what we used to do to go to the planetarium to see a simulated sky. And it lets you essentially simulate the sky. And the neat thing with a lot of the new smartphone apps is that as you move your phone around, the sky will shift and change to go along with where you're pointing. So that can be very straightforward.
Sorry to interrupt you.
No, that's right.
Yeah, is your microphone rubbing against something? I'm getting a little bit of scratchiness. Just maybe.
I'll see if I can find a bit of tape and tape it over. Yeah, I'm a person who, if you tie my hands, I stop speaking. So.
Yeah, so
I
big
tend
deal.
to move.
I'll let you know if it's better, but it is what it is. But just figured it might be a little
Okay,
distracting.
no, thank you very much. Because of course I cannot hear myself as is. So, and hopefully the sound won't break up too much. It might break up as I'm shifting from one piece of software to the other. Okay, so when you start up Stellarium, typically on the very initial startup, it'll ask you for your location. You type in Edmonton, and boom, it knows where you are on the planet, and it reads the time off of your computer, so it'll actually show you the current time. And you can actually play with the time. For example, very simply, both the bottom pops up a menu, and if you go over to the side, it pops up a different menu. And things are fairly intuitive. So date time window. So for example, if I go an hour earlier, well, there's the sun, and you sort of can't really see Venus anymore. But once the sun sets, and you can actually have this roll on real time, so it matches the current time of your computer. And there are other options where you can actually make it run 10 times faster than real time or 20 times faster, and so you can have things scroll by during as you watch. It's nice and sort of click and drag, and you can change directions. You can actually, although I haven't done it here, take a picture or a set of pictures and create a panorama of my location and ingest it into the program and have your backyard or your cottage terrain show up right in the software itself. You can also say that you're on Mars or on the Moon or on Saturn, and the whole backgrounds change. And when you say you're on Mars, it'll actually show you like Mars's North Pole star is not Polaris, it's something else, and you can actually go and and sort of visit probably a little too much at this point. Just with Venus is past sun and moon. This is the brightest object in the sky, and it is prominent. Early, you want to wait 30-45 minutes after sunset for it to be super obvious. But if you know where to look and you're sharp-eyed, you can actually see it during the day. But let's start with the evening hours here after we finish this session. Looks like skies are actually going to be fairly decent later this evening. You should be able to walk outside and look to the west. And I should actually preface things a little bit with directions. I don't want to assume that everybody knows what north, east, south, and west are. I've heard the acronym, like, how do you remember? Well, north is up, so that's the nice thing. South is to the bottom, like in all sort of maps of the world and maps of Canada. But you know, whether some people who are not science based and don't have a good sense of geography might get confused as to which side is east and which is west. On a map, as you're looking down, the acronym is never eat soggy wieners as you go around the clock. So N at 12 o'clock, north, east at 3 o'clock, south at 6 o'clock, and west at 9 o'clock. So never eat soggy wieners. And then you'll find after a few months, you'll know this like the back of your hand. But east is where the sun rises, more or less, and west is where it sets. So right now on Stellarium, we're looking at the western sky in twilight times. So Venus is the second planet from the sun. And it's also that serves as a reminder that as much as I love the sky, in grade 7, I did not know the order of the planets. So I had to start from ground zero, much as everyone else. I've accumulated a lot of information since then, but it's okay if you know nothing, don't know the names or the orders of the planets or anything like that. Very slowly and bit by bit, you'll pick it up. So Venus orbits around the sun. Most of the planets will orbit the sun as in a almost flat disk, like a record from a record player for the older folks among us, or a DVD for the younger ones out there, and that with the sun in the center and the planets all doing orbits around the sun. To a first approximation, the orbits, you can just look at them as circles. As you'll find out later, in detail, they're not quite circles, they're ellipses, slightly oval, but for all intents and purposes, just sort of think of them as a circle or a circular racetrack. So not like the oval racetrack that you would have at the Olympics for the runners, but a completely round one. And so Venus orbits on the inside of us, and that's why it's always not too far from the sun. We see it only in the morning or only in the evening. And then if it's smack in between us and the sun, we can't see it because the sky is too bright. And if it's on the other side of the solar system, we can't see it again because the sky is so bright around the sun. Now, one of the things that's really interesting, you've probably seen Venus. It looks like an airplane coming in for landing with its lights on. It's so bright. Although I have heard that some people have thought, oh, I thought that was this comet that's going to be visible in daylight that's been making the news. And it's just like, nope, it isn't. That has yet to occur and actually might not occur, but that's a subject for probably Jeff's session in 2 weeks. So that brilliant light up in the west is the second planet from the sun, Venus. And it is completely cloud covered, a little smaller than our fair Earth, but it's completely cloud covered. And so with the white surface, or pardon, the white clouds, it reflects the sunlight very easily. And so that is one of the reasons why it's really bright. But one of the neat things that's happening is it seems like it's been hanging there for almost 3 months, and it is in just over about 6 weeks' time, it'll disappear out of our sky, kind of like a pop fly to the outfield. It just hangs and hangs and hangs, and then all of a sudden, boom, comes down. But what is happening is, if you think of that Olympic running racetrack with Venus on the inside track, not only is it on a shorter track, but it is actually moving faster than we are. But as will often happen in a running race, if somebody ends up lapping you because they're faster, when they're behind you or on the other side of the track, it seems like they're hardly moving at all. And then bit by bit, oh yeah, they're sort of catching up. And then when they get to you, they just appear to blow right past you. And essentially, that's kind of what Venus is doing. Its speed is almost constant, but it's just that relative change from coming from essentially behind us to zipping between us and the center of the track, which is the sun. And so in 6 weeks, it will be in front, in between us and the sun, and completely out of the sky. The other thing that will happen is if you do have a chance to look through a telescope, even the smallest of telescopes, Venus right now shows a half moon like phase to it. You cannot see any details on it, but the shape will be like a big capital B. And over the next 6 weeks, that will be slowly thinning out to become looking more and more like a thin crescent moon, and it'll be getting bigger and bigger. Big enough that in binoculars, you'd be able to see, oh, that's not round. So that'll be something I'll leave to Jeff to remind you of. Okay, John, are there any questions about Venus at this point? If not, I'll move on to the next piece.
Yeah, no, nothing on Venus. We had one question about the binocular recommendation, but you were gonna get to that later. So just want to make sure we're not ignoring it. But yeah.
Okay.
Nothing on Venus.
Okay. And I will share my screen again, but this time with something else. Okay. Oh, so John, can you see my mouse? I hope so. It's up in the upper left? Okay.
Yes, you're at the wax and give us right now.
Yeah. Okay.
I just don't want to get it confused with my mouse.
Okay, so among the sort of the most obvious things in the sky, and especially the night sky, is the moon. So we'll cover a few things about it. It's actually only recently, as in the last 30 to years or so, that the hypothesis on how the moon came to be, it's instead of, like you may be familiar with the term the Big Bang, how the universe started, well, how we got the moon is nicknamed the Great Splat. And essentially they figure a small planet-sized, Mars-sized half planet smucked into the Earth about 4 billion years ago or so, and the remnants of it came to become the moon. And so that's now in orbit. So the moon is essentially now a dead rock, pretty much solid all the way through, as figured out by some of the instruments that the Apollo astronauts left on. But that's an aside. So the moon goes through a whole bunch of phases, and I've heard at one point where somebody said, "Oh, I thought new moon was the full moon," and it's the short answer is, "Oh, unfortunately, you're mistaken. New refers to the time where it's in between us and the sun, and it is not lit. The front side of it is lit. So essentially the sun coming to hit this ball that's in front of the Earth, not to scale here, by the way, the side facing the sun is lit, but the side that the Earth sees is completely dark. And it's the complete opposite 2 weeks later, give or take, where the moon is on the opposite side. The sunlight comes and gives us day side here, but those of us at night will be able to see the moon fully lit here. One of the other things that we talk about, and is actually on this poster here, is you'll see a first quarter moon and third quarter moon. And for those who are just starting astronomy, one of the first questions is, why do they call it a quarter if there's a half of it? And what the quarter refers to is where it is in its orbit. So think of the orbit as starting out as 0 here. It goes 1/4 of a circle, 2/4 of a circle to full 3/4 of a circle, and then finally back around to the starting point. And so if that's essentially the short explanation as to why we have a first quarter moon and a third quarter moon, and it's not a quarter of it, but it's a half lit. The two terms are somewhat confusing, but that's the reason why we call it a quarter. Now, how much of it is lit depends on at what point it is in its orbit. And you can actually, if you hold up a tennis ball, say in the afternoon, we're coming up to the point where we're just about at new moon. I think we just passed it. Did we? No, it's today is new moon. So the moon is right between us and the sun. And in about 2 evenings, we'll see a very thin crescent, much thinner than this. And over the next few evenings after that, it'll take about a week. So a week tonight, we'll be able to see a first quarter moon. And so if you actually take, say, a tennis ball and hold it up to the moon, as you stretch out your arm and almost cover the moon, essentially the lit part of the tennis ball will have exactly the same phase as the lit part of the moon, and you're only able to see the part that the sun is currently lighting up. There is no thank you to Pink Floyd for The Dark Side of the Moon. Love the music, but unfortunately, people think there's a part of the moon that is dark, or half of it is dark, and it's only dark half the time, just like the Earth. There is no dark side of the Earth other than the place where it's currently nighttime. So the moon's day is actually an entire month, 30 days worth is how long a day lasts or a day and night last on the moon. 12 hours of daylight for us is 2 weeks of daylight on the moon. And so it does slowly turn, and then eventually it becomes full 2 weeks from tonight, give or take. And one of the neat sayings to remember is slightly catchy phrase: the full moon rises at sunset and sets at sunrise. So I'll go over that a little more slowly. So if you imagine the situation at full moon, during the day, if we're on the day side of the Earth, at noon, the sun is directly in front of us to the south. And so the full moon will be behind us through the Earth, so we cannot see it. But once we rotate around to sunset, so as we're getting into the 11 p.m. part of this clock here, that's when we will see the full moon rise, and then the full moon will be highest in the sky when it is our sort of local midnight. And then as the Earth continues to spin and we come around to this side here, the full moon will set just as the sun will be rising. So you can never see a full moon at noon during the day, because it's on the other side of the planet. And so there are some times, like right now, no one on our planet can see the moon because it's only out during the day in the same part of the sky as the sun is. And so it doesn't matter where you are, there's no moon to be seen. And new moon is especially interesting to the people among us who do a lot of what we call astro imaging, taking pictures of the night sky. Because if there's no moon in the sky, that means the sky is nice and dark, and we can take some really nice pictures. When the moon is full, once you get your eyes adapted to it, it's actually pretty bright out. You know, you can walk very easily around without tripping on anything, because there's so much light once you're well adapted to the night. Oh, the other terms on here that you'll hear a lot is waxing and waning. So waning, I find it easiest just to think of waning is it's as if you're sort of becoming weaker and weaker. And that's essentially what that means. After full moon, the moon gets less and less, and so it's called, that's the waning part of its cycle. It's a funny term, gibbous, for meaning not quite full. I don't actually know the roots for that. And then on the waxing side, you'll see waxing crescent, waxing gibbous is when the moon is becoming bigger and bigger. So people who are familiar with Shakespeare and that will have heard words like waxing, but you basically don't hear that term at all these days, except we're talking about a waxing crescent moon. And so that will cover the early introduction to the phases of the moon. Among the things we'll be doing either later in the year or into the next sessions is go into more details about the moon's orbit. There's actually a whole bunch of stuff going on that we'll explain a little bit later. One of the things, and this reminds me, I forgot to mention in the introduction, is you can kind of follow along in something that the Royal Astronomical Society of Canada explores. It's called Explore the Universe. There's a booklet that goes along with it, but there's a free sort of observing program. You can download the PDF and print it out, and essentially follow along, and once we get through this in a year's time, you will have basically earned a Explore the Universe certificate, and the Society will also issue you a pin, um, as in a lapel pin, if as long as you go through the program and jot down your observation notes that are in the program guide that's available at rasc.ca. And it's important to hear say that one of the special features of this program is that it can be completed entirely using the unaided eye and binoculars. A choice of objects is provided, so you can start the program at any time of the year and easily complete the requirements in 6 months' time or so. Typically, they will give you twice as much stuff as you actually need, or looking at it the other way, you only need to complete half of it, of each section, to earn your Explore the Universe certificate and pin. Okay, with that.
Just want to point out, Alister, do you have the URL for the Explore the Universe program?
Yes,
Is that in your new?
I copied and pasted it into the Q&A section. So hopefully everybody
Excellent.
can actually see that.
Yeah, so that's a question that Mandy Miner's not asked. So you have that copied and pasted in. I don't see it in the question and answer.
I wonder, I wonder, I thought it said show all. And there's a segment that ends with, or it starts with the International Space Station and satellites, if you scroll all the way down through that. Or maybe I didn't send it. Ha, let me click.
I don't believe you sent it yet.
Okay, I just clicked send, so we'll see if it shows up.
Perfect. And Luca was pointing out his question was actually the definition of gibbous, having the observable illuminated part greater than a semicircle and less than a circle. So that's the actual definition. So thank you, Luca, for that. I was also going to ask, just as a general thing, hopefully this isn't taking you off too much of a tangent, but if someone has a little telescope or binoculars they want to set up in their backyard, the moon is a good target to start with. Do you have a recommended time to look at it, or maybe some features, or a rough overview, not to take everything out, but on the moon?
Well, in 2 weeks' time, that'll be really appropriate for Jeff to be talking about what's up in the sky, because the moon will be full at the time. Oh, but just to say, I know a lot of people who think, oh, the full moon is the best time to see the moon because it's bright and it's full. But oddly enough, the best time is actually not full moon, but also not new moon now, because the full moon it does have some interesting things to look at, but even more interesting stuff happens when it is either in crescent first quarter or the waxing gibbous part, because we get to see craters, and even in binoculars you can see some of the biggest craters, and it's only when they're illuminated from the side and casting shadows that we get to see a lot of detail. And it's surprising just how much detail. There is just so much that's available on the moon. But at the moment, I don't want to cover that since I think we're going to be pushing time. So, but having said that, you can probably find on the internet free downloadable moon maps that will show you the basic features on the moon. Night Watch also will have moon maps as well as the Observer's Handbook that comes as a member benefit to the Royal Astronomical Society of Canada. I am going to swap my screen back to Stellarium, and we'll talk just a little bit about the Dippers and Polaris. So, I need to actually click share. Here we go. Okay, so what I'm going to do is I'm going to advance the time to night. There we go. Poof. If only we could have such control by ourselves. And like zooming in and out is just rolling your mouse around. Okay, so the where are we? The looking north, and what you'll generally see first is this off-kiltered. I'll just drag this front. What you might see first, because it's a little closer to the horizon, is this W pattern. That's the constellation Cassiopeia. We'll get into names next session. There are a lot of names of things, but don't worry, you don't really need to memorize anything, but you'll pick up names just as quickly as you would after being introduced to people and trying to remember their names. But as you look north, and Polaris will be one of the stars, and certainly not the brightest one around. Oh yeah, and I was going to mention the living in Edmonton. We've got a fairly good idea of where north is, because most of our streets are aligned straight north-south and our avenues east-west. So if you're a little lost for direction, if you're on the main grid of streets and avenues, it's the street points north, the opposite direction to the sun during the day. Now, the Big Dipper will be one of the most familiar groups of stars out there. Now, you will hear the words constellation and also asterism. Asterism is going to be a word that very few people on their first day of astronomy will ever have heard. Asterism is just a fancy Latin word for group of stars. And the Big Dipper is going to be almost overhead. Like the overhead point is essentially at the top of the screen here, so it's very high up, but it'll be relatively prominent even in the city. They are among the brighter stars, and the pattern with the curved handle is fairly prominent. Now, the neat thing you can do with, oh, I got the wrong ones here. There we go. With Stellarium is you can actually turn on the constellations. You can also choose Chinese constellations, Arabic constellations, sort of just about you name it, and you can see the sky as it does there. You can also turn on and off the lines, which are part of the constellations. But in short, the constellation is one of the figures, and it usually represents something out of mythology or something out of the culture of the society. So, for example, several cultures they don't have the great bear. And of course, how many of those people ever saw a bear? Because we ain't got no bears with tails like that. Even the little bear, has a long tail here. But let me just turn off the fanciful figures and go back here. So here we can actually see that the Big Dipper is actually part of a bigger group of stars, but it's certainly the other stars you'll only learn after a little while, because they are fainter, especially from the city. You'll only really see the stars of the Dipper itself. If you suddenly go out to the country and you haven't been in the country sky for a long time, you can be overwhelmed by all the stars so much that you sort of can't even recognize things like the Big Dipper. It takes a little while to orient yourself. So this is the position in spring for the Big Dipper. 6 months from now, it'll actually be down low towards the horizon, but we'll get there as time goes on. As we look towards the north, the stars circle in a counterclockwise direction, and so one of the Inuit myths that as to why the stars are there is that it's 3 hunters who are chasing 4 elk. And because the stars go in a counterclockwise direction, it makes sense that those 3 hunters would be chasing the elk, which are out in front of them. So essentially, every culture has its own meaning to what the stars are, where they came from, and I find it's a very interesting way of communicating the culture to the next generation. As it happens, we know these constellations. You'll hear us say Ursa Major instead of the Great Bear, or you'll hear us say Auriga. Let me get rid of the thing here. So Auriga is this pattern here. You'll almost never hear us say the Charioteer. But all these groups have, and constellations have part of the mythology. And for us on the western side of the culture, those myths come from the Greeks and Romans. And so primarily that's what they are. And so the Latin names is what is now sort of stuck to the sky, and that is how you'll hear us speak. We'll always refer to Ursa Major, Ursa Minor, Cassiopeia here, which is a queen sitting on her throne. Well, good luck imagining that. So there's a lot of constellations that don't look anything like what their name is. I mean, even the patterns of the stars around the Big Dipper and Ursa Major, it's just like I don't see a bear there. But don't worry about it. Sometimes people's names don't look like who they look like. It's just the way it is. So you'll learn about that. One of the things you should try and do tonight, since it's going to be clear, is learn one of the very first things that we all learn especially in the springtime, is a way of remembering the names of this star here, Arcturus. It's a beautiful orange bright star, one of the brightest stars in the sky. And we remember its name by thinking of the handle of the Big Dipper as an arc, and so we call it arc to Arcturus. And Arcturus is the name of this star. I won't go into how it got its name in particular, but that's a whole nother very interesting set of things. The names of the stars, many of them are Arabic in their etymology, in their origin. And that's in part because after the fall of the Roman Empire, while we were in the medieval world, the very sharp-minded Arabs were going about with progress, and they actually transcribed a lot of the Greek and Latin texts into Arabic. And then once the Renaissance started going, those were retranslated back into Greek and well, Italian rather than Latin. And so the names of things actually kind of get warped as they go along in time. So sometimes the names are actually semi-meaningless. They just end up being a bunch of words. But many of the names you'll be hearing, like Altair, Alberio, Alcade. A lot of names start with AL, which is just about means the in Old Arabic. But remember this arc to Arcturus. And then the other thing is way off to the southeast, lower down in the sky, there'll be a fairly bright blue-white star. And its name is Spica. It's part of the constellation of Virgo, which is very difficult to see in the city, but out in the country you can kind of imagine a body reclining here. But the whole thing to remember, and that'll be 1/6 of what you need for your part of your Explore the Universe certificate, is to remember or learn how to identify this arc to Arcturus and spike to Spica. So arc to Arcturus, spike to Spica. And so that will be mostly what your sort of homework, so to speak. And I'll end on one more off to the south now. So where the sun is at noon towards, so looking south along the street, about a third of the way up the sky is another blue-white star, and that is called Regulus. And again, Jeff will be refreshing you on that next time. And if the name Regulus rings a bell from the Harry Potter series, there's also Sirius Black, Regulus, his brother Regulus. The author took quite a few names from the sky and used them as the names of people in Harry Potter. So Regulus there, but remember again, arc to Arcturus, spike to Spica. And if you only need to do that about 5 or 6 times, and you'll remember it, and try and keep a sense of how much sky that takes up. So from essentially way overhead with the Dipper, and then coming pretty much almost all the way to the horizon in the south. And as the night progresses, these will rotate around to the right. So I'll just end on, we'll go up to midnight here, and we'll come back facing north. And these maps can take a little getting used to because they cover the entire sky. But as the sky essentially rotates around Polaris, that will get out of the way. So at midnight, Venus is almost set. And I almost forgot one of the key points that I was going to touch on here is that the bowl of the Dipper, we call these the pointer stars because they point exactly to Polaris, which is due north here. It's not exactly north for reasons we'll get into later, but as in a new session, but it's as close as can be for if you're lost and it's at night and you can see the Big Dipper. You just look for these pointer stars from the end of the bowl, and they will point to Polaris, which is due north. The Little Dipper, I should mention here, is actually very hard to see unless you're out in the country. The other parts of the Dipper stars are basically invisible, or right in here. But we'll see that. Oh, and again, I missed saying, many people have think they've seen the Little Dipper, but as it turns out, I'll have to change the month here. There we go. What they very likely were seeing is something we call the Pleiades, and Venus went right past them just a couple of weeks ago. People with good eyesight can see the Pleiades about like this. They can see 5 or 6, maybe 7 if you're really sharp-eyed, stars in a very small group, as in this is how small they are. I'm zooming out now, just a tiny little group. But they'll say, oh, that's the Little Dipper. Not quite. It is a Little Dipper, but it is not the Little Dipper. This is actually a group in Western mythology called the Pleiades, the Seven Sisters. And for those of you, even if you're not a car fanatic, you'll recognize the name Subaru. And they did not name this cluster after the car. It was the other way around. The parent company, Subaru, named their company after the group of stars that is in Japanese called Subaru. So I will end there, and we'll go to the question and answer. I'll stop sharing, and you can actually.
Yeah, there wasn't much in the way of questions, Mandy. We got the website. She found it herself, and you were going to list some online resources for us. Are you going to post
I did.
In the question? Or where are you posting them?
Well, actually, if you put in the if you re-put in the question there, I can copy and paste them in again. So
I don't know if I can ask. Maybe I'll ask Luca if he's paying attention to ask that question for Alister. Nicole is asking a good question. When is the next session? So that's great.
Yes, very appropriate. Thank you. So the next session in this introduction to stargazing and the universe is the 4th Wednesday of the month. But as a also reminder that in 2 weeks' time, the 1st Wednesday of the month will be Jeff Robertson's What's Up in the Sky this month. So there'll be some overlap, but you'll get to hear a slightly different take on things, because Jeff will be concentrating on what actually is up in the sky. So that will be 2 weeks from now, 1st Wednesday of the month. And my next session here will be the 4th Wednesday of the month.
And then Luca has posted that question. So if you can cut and paste the answer in there, then hopefully everyone can see those answers as well. I believe.
It's a long answer.
Yes.
Where all the sorry, the intent was to have that out earlier. So we'll keep running so that people have time to copy paste that.
And then maybe for the longer one, we could go back to Cole's question about a good binocular kit to buy as a beginner. Do we have any? I could give a little bit too, but I think you probably have some good answers on that.
Other than well, one of in part it depends on what you're looking for. A good entry-level pair of binoculars are probably on the order of $200 plus or minus. There are some good recommendations on the Sky News website. So it would be Sky news.ca has some recommended binoculars. Um, it's kind of tough to go through the whole lot. There are some very expensive but amazing binoculars that have image stabilizers built in, and those unfortunately are $800 plus, but they're really nice because surprisingly, and especially at night, you tend to jiggle a lot more than you think. One of the classic ways to slow down binocular jiggle is to lean against a building or prop your elbows on the hood or roof of a car to stabilize yourself. But it just even like if you have binoculars to start with, don't go out and buy any. What you've got already is probably pretty reasonable as long as they haven't been dropped too hard and out of alignment. But generally, you'd be looking for something like what's called 7x50. 50 is the aperture in millimeters of the front lens, and 7x is the power or magnification. So if they're 6 by 43 or 9 by 55, it's okay as long as it's somewhere around 40 to 55 on the second number, and somewhere between 6, 7, or 8 on the first number. Those are the typically the best suited for astronomy uses. But as I said again, just about whatever you've got is sort of better than nothing and a good place to start. It takes a little bit of practice focusing them, and so use them during the day, sight on something that's far away, and then don't adjust anything and then use them at night. That'll be your sort of first go at it.
Yeah, I'd also point out I wouldn't get anything above 10 times magnification because they're going to wobble all over the place. They're really hard to look at once they get that magnified. So your 7, 8, 9s would probably be better. That's one thing I'd point out. And reclining chair. If you have a lawn chair that reclines, pull that out, and it's a lot easier to look up with a set of binoculars when you're laying back on the ground or a sheet on the ground than craning your neck straight up. That gets old quickly too. So point that out. I guess the online resources were in the answer, and I was not smart enough to see them. So I believe it was Nicole gave that to us. So you were correct. You had them there. I just didn't see it. So yes, Nicole DeWert, thank you. So hopefully people have had a chance to copy and paste or screenshot that spot for all your great websites as a start.
In terms of getting binoculars, it may be very tempting on Kijiji. You can get good deals, but you can also get lemons fairly easily. And the thing to look for, especially in binoculars, is as you're holding them up. Well, these days, chances are you're going to need to wipe them with the Clorox first before you handhold anybody else's stuff. But you always want to be looking outside. Never look through a window because the window distorts the light quite a bit. And so absolutely high-end binoculars could give you very awful images if you're looking through a triple glazed window. So make sure you're outside when you do that. And you want to focus on something way, way down the street as much as possible. Because when things are nearby, they're just easier to see and to see the detail, whereas stuff that's towards the farther away and at the end of the street is what you want to be looking at. And then the key thing is, as you're looking through them, is blink from one eye to the other. Like just close your left eye, look through the right, then switch, close your right eye, look through the left. And if the image jumps, then don't get them. A proper set of binoculars should, when you're focused at and looking at something very far away, as you blink from one eye to the other, it should stay very, very close to not moving at all. So that's really the quick way of testing binoculars. If they're at all out of alignment, especially if they're one up and one down, yeah, you'll very quickly get headaches with that, as your brain tries to squeeze the images into something that it's used for, and so the average person, the average amateur astronomer doesn't have the skill set to take apart binoculars and realign them. That's very few people in an organization would have that skill set. So don't assume that, oh, I'll just get these and get Alister to tune them up. It's like, nope, I don't do that. So you're best just to move on to and try and find a better pair of binoculars. And just to emphasize again what John had said about the avoiding 10x, is that it's very easy to get into the frame of mind, well, if it's twice as big, it must be twice as good. And that is not at all how optics in astronomy work. And one of the things that especially comes around with telescopes is that a telescope that's twice as big is usually 8 times heavier. The mass goes up by the cube of the number. And so you think, oh, I've got this 8-inch telescope, a 10-inch should be fine. And a 10-inch becomes quite more unwieldy. And we've known many stories of people who bought with their eyes and oh, that looks really great, and then they realize, oh, I've got to cart this thing up and down a flight of stairs to the basement and back out, and before you know it, it's not used at all because it's just too big and unwieldy. So a lot of times something that's more compact can be the perfect thing for your setup. And everybody's house is different. Some people have balconies, some people don't have a back deck, and so it's just, yeah, don't rush in on this.
And some people don't like some people's girlfriends don't allow them to keep their telescopes in the living room. Mine haven't been kicked out yet, but we'll see.
Come on, a nice telescope is a work of art.
Thank you. My 10-inch.
But
beautiful.
But if it's at all like my telescope, that's hard concrete tube and pieces of PVC plumbing and bits of 8x4 plywood, yeah, it is not a piece of art. So my telescope is not in the living room.
It works. It works. That's all that matters. I was also going to point out, if someone did have binoculars to use in the backyard and they didn't focus them before, or they lost their focus, the perfect focus, or the best focus, is a star should be as small of a point of light as possible. And there are no more questions. So if you have any closing remarks, I think that could be the time for it. Otherwise.
Okay. Well, I'd like to say thank you. Thank you, John, for being the person behind the curtain, keeping an eye on things.
Yes,
And
thank you.
again, thank you, Luca, for having walked us through the whole Zoom. And to all our participants, thank you for showing up. And I hope that was informative and that you'll come back for the next session. And try not to worry if you find things hard to remember, like the Arcturus was the Arc to something or other. It takes a while to learn the names, but again, head outside as often as you can and just remember the 2 new things that you've learned this evening.
Yeah.
And before you know it, you'll have picked everything up. So, but as I said, if you can't remember, don't worry. We'll be here the next time around, and we'll help you through it. Before you know it, you'll be well versed in what's up in the sky.
Yeah, and I will be posting this on YouTube at my earliest convenience, so we'll be able to have a refresher too if you need that. And I think we had almost 17 people, so great turnout and excellent job, Alister.
Thank you very much. Have a good evening, everyone.